Hello and welcome to the solutions video for the May 5th set of assessments. This one has basically alphabetical or almost alphabetical order for our topics. We're going to start with algebra and number 1. The number, let's see, 1, 2, 3, 4. The number 635,040,000 when fully factored can be written as a to the b, c to the d, e to the f, g to the h, where a is less than c is less than e is less than g. So we want to write the number a, b, c, d, e, f, g in the blank. To start off with, we have to find the lowest prime factor in this. And it's even, so that means the lowest is 2. I take the number on my calculator, divide it by 2, I get 317,520,000. I then just hit divide by 2, so it gives me answer divided by 2. And I keep pressing enter until I get an odd answer. All right, so there were 8 of them. I am now down to 2,480,625. That's divisible by 3, so just hit divide by 3. And I can keep pressing enter and counting those until the response is no longer a multiple of 3. So that appears to be 4 factors of 3. That leaves me with 306 or 30,625. So I'm going to take the answer and divide it by 5. So that's 6,125, 1,225. That's 1, 2, 3, 4 factors of 5. I'm left with 49, which is 7 squared. Now, greatest common factor of 80 and 120. Again, our calculator can help, although here it is not super difficult to tell that it's 40. So 80 divided by 40 is 2, 120 divided by 40 is 3. So the least common multiple would be the product of these divided by 40. Again, we can type these into our calculators if we want to. Now here, the expression, the square root of the cube root of a to the 6 is equal to. Now for here, I'm going to go to the whiteboard. It is the square root of the cube root of a to the 6. This is actually easiest if we replace our radicals with fractional exponents. And now we have a number with a fractional exponent raised to a fraction, raised to a fraction. When we have a number raised to 3 exponents, we multiply them all together. That's a to the 1, which is option B. Now here, the square root of the cube root of a to the 18. Similar approach. So we have the square root of the cube root of a to the 18. That's a to the 18 inside brackets of exponent 1/3, inside brackets of exponent 1/2. So that's 1/6 times 18, a to the 18 over 6 is a cubed. So this wraps up our coverage of algebra and number 1. All right, continuing on to algebra and number 2. So we have the square root of 1 plus the square root of 2 plus the square root of 3 plus the square root of 4 plus x. All that equals 2. We have to solve for x. So, square root of 1 plus. Actually, I'm going to rethink the order I write this down. It'll be easier to have it line up if I start with the 4 plus x and take that root. and then build my way out, that will look better. Now to find x, we square both sides. And there's the issue I was dealing with last time. Squaring both sides, that makes this 4. So, again, working from the inside out. So this square root equals 3, subtracting 1 from each side. Square both sides again. This equals 9. Subtract 2 from each side. We now have a 7 on the right. Square both sides. And 3 plus the square root of 4 plus x is going to be 49, which tells us the root of 4 plus x is 46. Now we square both sides. 46 squared is going to be 6, 1, 1, 2. We subtract 4. And x is 2,112. All right, so chemical equilibrium equation applies. We have this, so A, B, and C are the concentrations of 3 different chemicals. Q is the equilibrium constant. Yeah, your science classes haven't hit there yet, but everything you need to do to solve it is in the problem. We have our formula. We know which variable we're being asked to solve for. We know the values of the other 3 variables. In the first, we're asked to solve for B. So, changing colors as we change questions. Q is C over A squared B cubed. So if we multiply both sides by B cubed and divide both sides by Q, we get this. So ultimately B is the cube root of this. Okay. So our value of C is 0.185 times a constant. So it's actually that M is units, so they don't affect the numeric calculation. Our A is 0.227 and Q is 613. That's all in the cube root. This is one where it might be good to review how we can store values in our calculator. This works with both the Casios and the TIs. The emulator I have is for the TIs online. On the Casio, your store button is above the on button. It's an arrow pointing to the right. It'll look exactly the same as this. So we're loading here. Please wait. Here's our TI-84 graphing calculator. That's what we're looking for. So in this case, we know A is 0.227. 0.227. I'm going to hit our store button and put it in A. Our C is 0.185. If we do this correctly, it's just going to give us the value, and our equilibrium constant is 613. So why go through the process of storing them? It'll actually make the next part much nicer to look at, because now we can effectively type our equation exactly as is. We know that's the cube root of c over a squared q. So I can write c down here, a, and we want to square that, and multiply that by q. Oh, I actually hit second function instead of alpha. And in fact, we can just hit alpha here. It understands the implied multiplication. So there is our b, 0.180, when rounded to the nearest thousandth as requested. The next one, we're given b and c and q and asked to find a. Algebraically, we have our same starting point. Q is c over a squared b cubed. To find a, we multiply both sides by a squared and divide both sides by q. So the a and the q can end up trading places. So then a is the square root of c over q b cubed. So in this case, b is 0.381, gets stored in b. 0.401 gets stored in c. Did it say 401, right? Yes, 401. And this time our equilibrium constant is 22.7. So now we have the square root of c over q b cubed. 0.565. All right. Next, identify all sets which include the number -6. It is not a natural number. Those are 1, 2, 3, and we keep counting. Negative numbers are not natural numbers. They are rational. It's an integer. It is real. It is not irrational. It's irrational or rational. We could write it as -6 over 1. That's a fraction. That makes it rational. And as a whole, again, that's 0, 1, 2, 3. The wholes do not allow radicals. The whole numbers do not allow negatives. Now, which set includes the number cube root of 37? That's not a perfect cube, so that's going to be an irrational number. And all irrational numbers are real. So this concludes coverage of algebra number 2. All right. So moving on to algebra number 3. The simplified form of this expression. Well, an exponent raised to an exponent, we multiply them. 5 times 2 is 10. We're looking for x to the 10. That narrows it down to a or c. Now 3 over 2 times 2 is 3. That makes it a. The expression then is not equivalent to 2x to the 4th to the -3 is, well, 2 to the -3 is going to be the same as 1 over 8. X to the -12 is going to be 1 over x to the 12. So the 8 has to be in the denominator here. X to the 2 to the negative 3 makes it an 8 or a 2 cubed in our denominator. So B is ruled out because 8 is in the wrong spot. 7, what does this simplify to? Let's look at our constants first. Looking at the multiple choice options, our constant is probably going to be 24 because we've got 2 to pick from with 24 and exactly 2. But 2 cubed is 8 times 3 is 24. Now, 3 times 3 is 9, and we have a 4. But here they both have the x basis, so the 9 and 4 do not multiply, they add. We can see here, if we multiply them, we'll find the answer. So we have to be careful. Now, our last one here, simplify this using only positive exponents. Okay, we are going to have a fraction. Our whole number is 5. That's raised to the 6. Right now, if we just bring that 6 in, it just applies equally well to everything. So we'll still have negative exponents, so this will not solve our problem, but it'll be a step in the right direction. Oh, sorry, I wrote an x there. That's a z to the 30. All right. So 5 exponent 6. Our calculators can help us with that one. Although it may not be much more informative than just leaving it as 5 to the 6th. I would accept both, I think, in this written response. Now x, we have 24 over a negative 30. So that negative 30 comes up to the numerator. 24 plus 30, because we're doing 24 minus negative 30, gives us x of type 24. That should be 54. We only have one y. That negative exponent brings it down, and 1z. There we go. This concludes our coverage of algebra number 3. All right, moving on to algebra number 4. So a student is multiplying this trinomial by a binomial using the box method. So the terms of the trinomial across the top, terms of the binomial down the side. And 2x squared times 3x is 6x cubed. We're looking for the student's mistake, trying to figure out what the correct answer is. 2x squared times 14 is 28. We can keep checking these one at a time, but each individual box has the correct value. Now, when the student multiplies it out, notice they've got a quadratic. It does not go to cubic. And what are these numbers? We don't see them anywhere up here. Well, 6 times 28 is 34. 42 plus 196 is 236 or 238. And 27 plus 126 is 153. So the mistake is adding columns instead of diagonals with equal exponents. That means the correct answer. We only have one term with x cubed. We have two terms with x squared. 42 and 28 makes 70. We have two terms that are linear in x. So that's 27 plus 196 to make 223. And we have a constant. So that is the correct response. Now, when this polynomial is fully simplified, the degree and leading coefficient, respectively, will be. Remember, degree will be the highest exponent. So 2 plus 0 is 2, 2 plus 3 is 5, 2 plus 2 is 4, 5 is the highest exponent. That's our degree. The leading coefficient is the coefficient of that exponent. We get that with 5 times 8. So this will be 40 as our leading coefficient. And when expanded and simplified, this one we have We'll use the whiteboard for this. 2x and 7x minus 3. Minus x. I think that was a 2x plus 3 in there. Yes. So multiplying our 2x through the first bracket gives us 14x squared minus 6x. Now we have a minus 2x squared minus 3x. We combine our x squared terms and our linear terms, and we get 12x squared minus 9x. That's option A. And the others are made from common errors. So when this expression is expanded and simplified, now we need our x squared term. So we can get that when we do 9 times our 1x squared. So we'll have 9 from that. The other way to get x squared is 5x times 2x. So we have a 10 and a 9. That makes 19. This concludes our coverage of AN4. All right, moving on to AN5. We want to factor these polynomials. Right, we have 8n squared minus 50. Okay, we have a binomial term. This is squared. There's no linear term. We go to a constant. So this, our best shot is going to be difference of perfect squares, but neither 8 nor 50 is a perfect square. They do, however, have a common factor of 2. If we factor that common factor out first, now we have a definite difference of perfect squares. So there we go. 2 times 2x minus 5, 2x plus 5. Again, using the equation editor is optional. I just find it is much nicer looking. So now we have p squared minus 9p plus 20. This has a coefficient of 1. So we are, and this has a positive number. If our constant is positive, we could factor this as two terms with the same sign. This middle term is negative, so they're both going to be p minus. So now we need factors of 20 that add up to 9. Well, 1 and 20 make 21, 2 and 10 make 12, 4 and 5 make 20. So we have p minus 4, p minus 5. We can write them in any order, so I'll just ignore that first typo. I was intending to do the 4 first. And now we're on C. 2x squared plus 13x plus 15. Two x squared plus 13x plus 15. So we need factors of 2. We have 1 and 2. Factors of 15, it's either 1 and 15 or 3 and 5. Again, our constant is positive. Our linear or middle term is positive, so all of our signs are going to be positive. So we need to somehow build a product with 1 and 2 and one of these pairs for the factors of 15, where we could find combinations that multiply and combine to make 13. Well, 2 times 5 is 10, and 1 times 3 is 3. So if we could force ourselves to multiply the 2 by the 5, or we could start this way because we know 2 has factors of 1 and 2. They both have to have x. They're both going to be positive. So we need to figure out where to slot the 3, where to slot the 5. We have to make sure the 2 multiplies the 5 or it doesn't work. So to put that in 2 different brackets. Then the 3 goes here. 2 times 5 is 10. And 3 times 1 is 3. That makes the 13. Plus 3. X plus 5. Now for these, if you are not sure, our calculators can help us. We can plot this. We had 2x squared plus 13x plus 15. We'll graph it. Looks like it hits this tick nicely. That one it misses a little bit. So we can go to our second function table. Look at our negative numbers. We have a 0. That is what we're looking for. This tells us that the function is 0 when x equals negative 5. That happens when you have an x plus 5. If we have x equals negative 5, well, that happens when x plus 5 is 0. So that makes x plus 5 one of our factors. This only really helps if we have integer factors. The other one's not an integer. So while we have pulled out the x plus 5 and can figure out from there what we need, we can also ask our calculator to find the zeros. It's asking us for a range, a left bound and a right bound. By default, it starts at x equals 0, or the middle of your picture. I want to find this 0 here. So I'm going to put the left bound to the left of that 0. Right bound to the right of that 0. And then it asks for a guess. We just get the arrow kind of close. And it says our 0 is at x equals negative 1.5. We can manually convert so that our x equals negative 1.5. We write that as a negative 3 over 2, which is the same as saying 2x is negative 3, which is the same as saying 2x plus 3 is 0. So our calculator can help us get both of these factors, because that's our 2x plus 3 now. This concludes our look at algebra and number 5. Okay, moving on to relations and functions 1. A student observes a population of wild birds in his area over a period of years. The following data are collected. So the graph of the student's data would be, it's either discrete and continuous or linear or nonlinear. So we are not necessarily going to have a fifth of a year. We are certainly not going to have a fifth of a bird. So this data is discrete. That tells us it's A or C. The question is the data linear or non-linear? Well, each of our time periods goes up by 1. So if our population goes up by the same amount every time, it's linear. Here it increases by 2, then 7, then 11. It's not the same, so it's not linear. Now here we've got a chart with astronomical data about Earth, Mercury, Neptune, Jupiter, Saturn, Uranus, and Venus. Now it says here, note that the cube of the distance from the sun is proportional to the square of the length of the year. So, as our distance from the sun increases, the length of the year increases. Not linearly, but it does. Something that's farther away will have a longer year. So which of the following planets will have the longest year? Which of these shows the greatest distance from the sun? Well, Neptune is the greatest one on the chart, but Neptune is not in the options. Uranus is the second highest in the chart, again, not in the options. Saturn is next in line, then Jupiter, then Earth, or then Mars, and then Earth as the shortest of these four. So which of the following planets will have the shortest day? That's the period of rotation, because we know Earth is 23.93 hours. Why not exactly 24, you say? Because the period of rotation is not relative to the sun, it's relative to the backdrop of the stars. So we have a 24-hour day because we are comparing when the sun is at the same position in the sky. So the shortest day, we're looking at these. Some of these periods of rotation are measured in days. We want hours for sure. So Neptune, Jupiter, Uranus, and Mercury. So Mercury is 59 days. That's out. Neptune, 16.2 hours. So that's the lowest so far. Jupiter is fewer hours. And Uranus is 17. So of these, it is Jupiter at about 9.85 hours. How many times further is Jupiter from the Sun compared to Venus? Well, Jupiter's distance from the Sun is 5.27. Venus is 0.72. So we take 5.27 and divide it by 0.72, and we get 7.32. And which planet is close to 1/5 as dense as Mercury? Okay. The density here, Mercury is 0.99. If we divide that by 5, we get 0.198. The closest to that is Uranus at 0.21. So that's the one closest to being as 1/5 of Mercury's density. So this concludes Relations and Functions 1. All right, continuing into Relations and Functions 2. Which of the following represents a function? Select all that apply. A function is something where each input produces only one output. We don't have repeated inputs, so that's a function. See repeats. No repeats. These repeat. So these two are both functions. Which of the following best describes a function? A relation with multiple outputs for single input is wrong. A type of equation used in algebra, technically correct, but it says which best describes a function. We can have much more precise definitions than that, so it's not the best description, most likely. A method for graphing data points. Now, you could graph data points that have nothing to do with functions. They're restricted to relations, so that's also not a great description. A relation where each input has exactly one output. That's our textbook definition. So that would be the best description of these. What is a relation in mathematics? A method to solve equations? No, not necessarily. A formula for calculating averages? No, that formula would be a relation, but not all relations are that formula. Typograph used in statistics. Again, a typograph used in statistics might be an example of a relation, but it doesn't describe all relations. Now, a way to describe a relationship between two sets of values. That's it. That's a relation. Now, if a relation is represented by the pairs W6, X5, X-9, and Y-8, what can be concluded? It has no outputs. No, that's not a conclusion we could draw because we see four outputs, 6, 5, -9, -8. It is not a function. This we can say because we have X appearing twice. One input, two outputs. So we cannot say it's a function because it's not. So it cannot be both a relation and a function if it's not a function. So now, how can a relation be represented? Select all that apply. It can be represented with ordered pairs. It can be represented with formulas and equations. It can be represented by a table of values. And it can be represented by a graph. So this is all of the above. All right, moving on to Relations and Functions 3. The points 12, 13, and h-4 are on the same line. And we have our slope. All right. So let's take a look at this. This will be easiest to solve if we write our line in slope point form, because we have a complete point and we have our slope. So let's do that. Let's say y minus 13. Our slope is 17 over 23. Our x is 12. So here is one point. We're going to be looking for the x coordinate of the other point. So, in fact, we can do our y minus 13 over 17 divided by 23 is x minus 12. So x is y minus 13 over 17 divided by 23 plus 12. And we're looking for it. X is h. And y is negative 4. Negative 4 minus 13 over 17 over 23 plus 12. Well, this over 23, that 23 can come to the numerator. So we have a negative 17 times 23 over 17 plus 12. We can cancel our 17s. That's a negative 23 plus 12, or negative 11. Plenty of boxes in case we make a mistake and have large fractions. Now our next quadrilateral ABCD has corners at A minus 69. Point B is negative 10, negative 9. C is negative 1, negative 6. And D is negative 6, 12. Is this quadrilateral a rectangle? Why or why not? Well, let's take a look at what we have here. Let's draw some axes. Our point, we have a negative 16, 9. That's point A. Point B is negative 10, negative 9. This drawing is not to scale clearly. C is negative 1, negative 6. And D is negative 6 and 12. So if this is a rectangle, it would be something like this. So if it is a rectangle, side AD would be parallel to side BC. And AD would be perpendicular to AB. We could also say AB has to be parallel to CD, and that BC is perpendicular to CD. So if opposite sides are parallel and we have 90-degree angles, then this works. So the slope of AB so B is at negative 9 for y and negative 10 for x. A is negative 16 and a positive 9. That gives us a negative 18 over 6. So the slope of AB is negative 3. The slope of BC so point C is at negative 1, negative 6. Point B is at negative 10, negative 9. That is a 3 over 9. That's a 1/3. So this is a 90-degree angle. That doesn't guarantee the other 3 are. So we have to keep looking. So C and D, so negative 1, negative 6, and negative 6, 12. And then our X was negative 6. Sorry. A little bit of lag really hits this. And our Y is 12. So that's a negative 18 over a positive 5. So this is not parallel to AB, nor is it perpendicular to BC. We could check the slope of DA, but it cannot work if one point doesn't work. So not a rectangle. AB not parallel to CD. CD is not perpendicular to BC, etc. Now, it is technically also possible, even though we haven't covered it in this course, to use our distance formula with the Pythagorean theorem and figure out what our distances are. And we will see that opposite sides are not the same length. I will accept that response because it is mathematically correct, and the question is not phrased as saying, is this a quadrilateral, use slopes to demonstrate? So that piece is not specified. So I will accept it if you can compare the distances, but this is the answer I was anticipating. And for full credit, you have to show the calculations of the slopes. All right. So here we have given these points, h18 and negative 17, 19 on the same line. This is actually very similar to question 9. So similar, in fact, that we could see the advantage to doing your manipulations first and your substitutions second. Because now we're asked for the same thing. We want to find the x value when our known point is at negative 19, negative 17. Our slope is 33 or 37 over 33. So then h, that's when y is 18. So 18 plus 19 over 37 over 33 minus 17. That's a 37 up here over the 37 over 33 minus 17. So this is 33 minus 17 or 16. Again, if I write too quickly, this doesn't keep up. Right, so This concludes our coverage of relations and functions 3. Moving on to relations and functions 4. When the question loads, here we go. Which of the table of values represents this graph? For starters, we know we have a point at 2, 7. So B has that point. Oh, and only B. We can go through and double check the rest if we want. Right, 0, 9, 4, 5. They'll all be there, but there's only one that has the point we randomly chosen to begin with. Okay, next, match each of the following to the corresponding linear relation. A bowling alley rents shoes for a flat rate of $5 and an additional $7 per game. So the 7 per game is that per. That's the key word that tells us we're dealing with slope, and our y-intercept is 5. That's C. Now, the equation of the line through negative 440 and 2, 2. Well, what slope is that? So, the change in y's, 2 minus negative 40, divided by the change in x, 2 minus negative 4. That gives us a slope of 7. That narrows it down to C or D. So we could quickly check just by substitution. If we let x equal 2, well then 7 times 2 is 14 plus 5 is 19. 2, 2 is not on point C, or not on line C. But our next one, equation aligned through these points, 7x minus 12. Yes, 7 times 2 is 14 minus 12 gives us 2. So that is D. Again, this table of values. Well, every time x goes up by 1, y goes down by 8. So we have a slope of negative 8. That makes it F. All right. And next, if this pattern were to continue, how many shots on goal would he have in game 8? So the first game was 1 shot on goal. Now 3, 5, 7. It's going up by 2 each time. Looks like it's at 2x minus 1 would actually describe it. 2 times 18 is 16 minus 1. That's 15. This concludes our look at relations and functions 4. All right. So now the domain of the function f of x equals negative 6x minus 8 is restricted to x greater than or equal to 0. This will restrict the range as well. So our function this time has a negative slope. If we graph this, negative 6x minus 8, negative 6x minus 8, if we graph this, we see if we restrict ourselves to only positive values of x, as we have here, well then y is going to be going down after that point. It has an upper limit. So y is going to be either less than or equal to. Because this restriction allows equal to, so does this one. And specifically, if x equals 0, y is negative 8. So in this case, the range is y less than or equal to negative 8. Right, so which of the following is an example of a function with a restricted domain? Okay, sorry, I said which of the following. It formats differently on the teacher side where the multiple choice is below the questions. But which of these is an example of a function with a restricted domain? Well, the 3 ways to take points out of your domain: division by 0, we don't have division. Square root of a negative, we definitely have square roots. And then logarithms. Which of the following functions are restricted ranges? Select all that apply. There's actually 2 here. It's A and C. X squared will have a restricted range because we can't make that negative using real number values for x. C also has restricted ranges because we don't have anything that matches negative values of x. So both A and C involve y greater than or equal to 0. So those two are restricted. Now, what are the domain and range of this function f of x equals 4x squared minus 6? Well, this one we haven't done explicitly in class, but we can graph it. 4x squared minus 6. If we graph that, okay, we see it curves and it continues on both sides. For our domain, we can see it's going to be x as a member of the real numbers because we don't have division, we don't have square roots of negatives, we don't have logarithms. So there's nothing to produce the exceptions. The range is limited. And we could try to figure out what it is. There's two options. Seems to happen around x equals 0. If we look at our table of values here, that's a y of negative 6. If we look at our equation, when x equals 0, that does produce negative 6. The third option, we can go to our calc feature, ask for the minimum, and again say somewhere between here and here. The guess here is optional because there's only really one possibility. This also agrees x equals 0, y equals negative 6. So we want y greater than or equal to negative 6. That's D. Now, similar setup for this one. F of x equals the square root of x plus 3. If we graph this, the graph magically appears at x equals negative 3 because that's when we're taking the square root of 0. That's totally legit. So our domain is x greater than or equal to negative 3. That looks like option L. And our range is y greater than or equal to 0. That's I. This concludes our look at RF5. Moving ahead to relations and function 6. We want to convert y minus 10 equals negative 9x minus 3 into slope-intercept form. We can do that by expanding and simplifying. So y minus 10 equals negative 9 times x minus 3. We could distribute the negative 9 through the brackets. Add 10 to both sides. And now we have slope-intercept form. So our slope is negative 9, and our intercept is 37. And we want to convert that same exact equation into standard form. Now, standard form means we're going to have no denominators, no common factors other than 1 in our coefficients. And we start with x having a positive coefficient with y on the same side of the equation. Standard form would technically have the constant on the other side of the equal sign. There's a lot of confusion about which is standard, which is general form. I will accept either. So we can achieve this form just by taking our negative 9x and moving it across to the other side. That gives us 9x plus y equals 37. I will also accept 9x plus y minus 37 equals 0. Now, which of the following is equivalent to y equals 6x minus 79? All right, we do have a few approaches here. These all seem to be based on the point 1115 or negative 11, 15, or 11, negative 15. Right? These all have 11s and 15s floating around. So here's a little trick we could use to help simplify. If we multiply the 6 by the 11, we're going to have a 66. Positive or negative. Add or subtract 15 from it. 66 is a multiple of 3. 15 is a multiple of 3. The result would have to be a multiple of 3. And negative 79 is not. So it can't be A or B. So now it's either C or D. So these are going to be 6x. 6 times 15 is 90. Forget negative 79, we need a negative 90 that we add 11 to. We can't take a positive 90 and subtract 79, so that has to be D. All right, so now we have 4 equations in standard form. We're looking for the following functions, or which of these functions has a slope of negative 6 over 7. Okay, so when we are isolating our y, that means our y has to have a coefficient of 7 based on this, because we have to divide by 7 to isolate it. Let's take a look, for example. So first, 6x minus 7y equals negative 2. These are all based on slope-intercept. So what I'm going to do is turn each of these in turn into slope-intercept form. So we have 6x minus 7y equals negative 2. So if we subtract 6x from both sides, we get a negative 7y equals negative 6x minus 2. Divide both sides by a negative 7. We'll have 6 over 7x plus 2 over 7. And this was multiple choice option A. So A has a slope of 6 over 7 and a y-intercept of 2 over 7. That's what question 33 is asking for. Now let's convert B. 7x minus 6y equals negative 2. Seven x minus 6y is negative 2. Negative 6y is a negative 7x minus 2. Y is 7 over 6x, dividing both sides by negative 6. And negative 2 divided by negative 6 works out to a positive 1 over 3. So this one was B. So we have a positive 7 over 6 and an intercept of 1/3. That's B. Next one to convert, the 7x plus 6y. Well, that's just going to change our signs. That's it. Because all we've done is change the sign on y. We end up dividing everything by that, so it's going to change the signs on everything. And that's the same arguing that D is just A with a sign change. So this concludes our look at relations and function 6. All right. Now, moving on to relations and functions 7. A linear relation passes through the points 8, 15 and is perpendicular to the line y minus 6 equals negative 3/10 x plus 5. We want to write the equation of the line in specified form. So first, slope point form. We know which point it goes through. Our slope point form is y minus y1. In this case, that's 15. We'll come back to the slope, m times x minus x1. So it goes through that point. Now it's perpendicular to a given line, and that given line has the slope of negative 3 over 10. So this has to have the slope of positive 10 over 3. Right? It just has to be the negative reciprocal. So that one is the easiest. That's why this is out of 1 point and the others are out of 2 each. Now, slope-intercept form. That takes a little bit of manipulation. So we have y minus 15 is 10 over 3. It's a 3. X minus 8. Okay. I'm going to multiply that 10 over 3 all the way through. And I'm going to add 15 to both sides. 15, written as a fraction over 3, is 45 over 3. So we have a negative 80 plus 45. That's a negative 35 over 3. So there we go. 10 over 3x minus 35 over 3. Y is 10 over 3x minus 35 over 3. Finally, general form. We can move our y from the left to the right from this one. So this will give us 10 over 3x minus y minus 35 over 3 is now all equal to 0. Then we multiply everything by 3. X minus 3y minus 35 equals 0. This concludes our look at RF7. So now moving ahead to Relations and Functions 8. This is on function notation. Yeah, I actually went too far. Didn't notice it had updated. All right. Given f of x equals 43 over 4x minus 6, we want to find f of 10. So that's a matter of substituting. I'm going to go back to using this storage technique. I'm going to make 10 the value of x. And I'm going to type 43 over 4. And minus 6. We have a decimal, but we don't have permission to use decimals. So we convert that into fraction. That's 203 over 2. And the next one, we're given the y value. We have to find our x. Well, y equals mx plus b. Y minus b equals m times x. Dividing both sides by m. Y minus b over m gives us our x value. So our y is 227 over 4. Our b is a negative 6, and our slope was 43 over 4. Yes, algebraically speaking, there are faster ways to get there. But I do like to show how to use the resources you have available. As a fraction, we have 251 over 43. now here, what is f of 2? Again, the 2 is in the bracket where the x goes. That means we replace the x with 2. 26 minus 7 is 19. Now here, the 84 is out of the bracket. The x is still there. It's telling us to find x. So we're looking for x when y is 84. 84 plus 7 is 91. 91 over 13 is 7. Here we substitute. 13 times 28 minus 7 is 357. 13 times negative 27 minus 7 is negative 358. We add these up, we're going to get negative 1. And that concludes our look at relations and functions 8. All right, moving on to relations and functions 9. We have this system of equations. We want to find the value of p to 1 decimal. Okay, so I'm going to do this by substitution. The reason I'm choosing substitution is our second equation. First one, 4p plus 3q plus 15.5. On our second, notice that our coefficients are 2 and 8. They're both multiples of 2. So if we divide both by 2 right off the bat, I think we had a 63.0. We divide that by 2. That gives us 31.5, where here the question did give us permission to use decimals. That tells us that p is negative 4q minus 31.5. I'm going to substitute that right up here. The reason I picked substitution is recognizing those are both even. We could divide it by 2, and then we have just p on its own. So 4 times negative 4q minus 31.5. Plus 3q plus 15.5 is 0. So first multiplying by the 4, we have a negative 16q. Now 4 times a negative 31.5. That's negative 126. Plus 3q plus 15.5 is 0. Collecting like terms. Negative 13q minus 110.5, if I've done that mental math correctly. So then q is 110.5 over a negative 13. And that works out to a negative 8.5. If we substitute that in, here, negative 4 times negative 8.5 minus 31.5. So our P ultimately is 2.5. So P is 2.5 and Q is negative 8.5. here we have a similar idea. I used substitution last time, so I'll use elimination this time, even though we have that same advantage for substitution. You are under no obligation to use a particular method. We could even use the method I showed you guys in class where we use our calculators. So, the value of A expressed to 1 decimal. So we have a 2A plus 8B is negative 55.0. 2A plus 8B is negative 55.0. And A plus 5B is a negative. Was that a negative? Yes. A plus 5B is negative 32.4. So for elimination, I'm going to multiply this whole thing by 2. Then we have a 2A plus 8B is negative 55.0. And down below, we have 2A plus 10B is a negative 64.8. Now, we have 2 A's here. So I'm going to subtract the bottom equation from the top. 2A minus 2A is 0. 8B minus 10B is a negative 2B. And a negative 55 minus a negative 64.8, I believe works out to a positive 9.8. Divide that by a negative 2. And B is negative 4.9. So if B is a negative 4.9, we could substitute that back up here to get A. Negative 32.8 minus 5 times a negative 4.9. So A is a negative 7.9. Here we want to solve this system of equations. We want to solve it graphically. So for this one, you've got graph paper on your response. You need to try and make sure that those who are physically present have graph paper that they could draw on as well if they're doing this on paper. I need to check to see if that's a possibility here. Anyway, we need to graph these equations. X minus 3y plus 120. Well, if we do it, let's do it step by step here. If we let y equal 0, then we have x plus 120 is 0. So that gives us an x-intercept of negative 120 and 0, because x plus 120 equals 0. So we're going to label that. We'll go, for now, I'm going to change our x and y axes to go between plus and minus 150. So that's our x-intercept. Our y-intercept, if x is 0, then we'll have 3y equals 120, or y equals 40. So that's a point. So our rise is 40, our run is 120. So this has a slope of 1 over 3. So if we were to graph this, right, we take out our pencil, our ruler. And when y is 0, x is 120. There we go. So there's our first line. Now our second line, when we're graphing it, x plus 2y plus 20 is 0. When y is 0, we have x plus 20 is 0. So this one is going to have negative 20 for our x-intercept. Our y-intercept, x is 0, 2y plus 20 equals 0. So 2y is negative 20, y is negative 10. So 0, negative 10, that's our y. So rise over run, we go down 10 and right 20. So our slope is negative 1/2. And again, I'm going to do it in slope point form, where I'm picking the point where y is 0. Confirm that these two cross. Now these count, or these intersect 2 boxes up, where each box represents 10. 6 boxes left, again each box represents 10. Looks like our solution, our point of intersection, is negative 60, 20. Yes, Desmos confirms. So there's our negative 60, 20. And verify the solution algebraically. So negative 60 minus 3 times 20 plus 120. That's a negative 60 minus 60 plus 120. Negative 120 plus 120, that's 0. So the point is definitely on our first line. We need to show that it's also on the second. Negative 60 plus 40 plus 20 is negative 60 plus 60, and that's 0. Both equations are true. Both equations must pass through this point. That wraps up relations and functions 9. I see that I have measurement 1 listed here. I'm going to skip over those questions because nobody asked to assess in measurement 1 for May 5th. So I'm going to use those same questions on the May 12th assessment, because why write more? I think I've written enough this year. So here we are, moving into measurement 2. We have some converting units here. We want to convert 22.3 meters per second into kilometers per hour. So 22.3 meters per second. If we want to convert meters into kilometers, we're going to need to cancel the meters, so that has to be in the denominator, get our kilometers in the numerator. And what do they equal? We can only multiply by 1. We can't change the value. So 1 kilometer equals 1,000 meters. We also need to eliminate seconds in favor of hours. We could do it in one step if you want, but really 60 seconds makes 1 minute. So we converted seconds to minutes now. And 60 minutes makes 1 hour. So when we multiply these out, we'll have 2 60s and 1,000. Ultimately, this works out to taking our 22.3 and multiplying by 3.6. So this works out to 80.28 kilometers per hour. It specifically says 3-digit answer. 80.28 rounds to 80.3. Now here, this is going to be scientific notation. 1.8 kilometers is how many inches? Okay, well, 1.8 kilometers. We could convert centimeters into kilometers. Let's start by saying we have 100 centimeters in 1 meter. And 1,000 meters for 1 kilometer. This will turn it into centimeters. And 1 inch is 2.54 centimeters. Just to track it, because there's a few here. These kilometers will cancel these kilometers. These meters will cancel these meters. These centimeters will cancel these centimeters. The only unit we'll have left is inches. So we take 1.8 times 100 times 1,000 and divide it by 2.54. And I've got 70866.14. Actually, let's do that on this calculator. 1.8 times 100 times 1,000 divided by 2.54. All right, we have this. If you are not sure, we can jump into mode. And we could tell it, give me the answer in scientific notation. Hit enter to redo that entry. And there we are, 7.08. Now we want 2 digits after that decimal. So change it from floating point to 2. 7.09 times 10 to the 4. So in this notation, that's 7094. Now our next is similar, 2.0 yards into inches. Well, 1 yard is 3 feet. 1 foot is 12 inches. So we could take that same 2.0 times the 3 feet per yard and 12 inches per foot. We're still in scientific notation because we're asked for it. 7.20 times 10 to the 1. Or 72. Meters per inches. 5 meters times 100 turns it into centimeters. Divided by 2.54, that makes it inches. 1.97 times 10 to the 2. Now our next one, we need to do a little bit of algebra. We are given a temperature in Fahrenheit. We need to turn it into a temperature in Celsius. So Fahrenheit is 9 over 5C plus 32. Fahrenheit minus 32 is 9 over 5C. Times Fahrenheit minus 32 is 9 times Celsius, and our Celsius temperature then becomes 5 over 9 times Fahrenheit minus 32. Our temperature in Fahrenheit here is 57.1. So I'm going to take here 5 over 9, 57.1 minus 32, 1.39 times 10 to the 1. This wraps up measurement 2. And just to play it safe, I'm going to go back to our normal mode and to our floating point decimals, now that we're done this set of questions, so that it gives us the outputs we are looking for. All right, next up, measurement 3. A right rectangular prism has dimensions of 16 centimeters by 4.6 centimeters by 5.4 centimeters. Find the volume of the largest cylinder that can fit inside the prism, measured to the nearest square centimeter. Okay, so one of these was actually a lot bigger than the rest. So here's one side. Here is our cylinder, or our rectangular box. Now the biggest cylinder we could fit inside is going to have a circular top somewhere up here, matching circular spaces at the bottom. So from a top view, we're going to have a rectangle and the biggest cylinder we could fit, hang on, it should come right out of that corner. We'll have a perfect circle that fits inside. So if we want the biggest one possible, we are going to have, in this case, the height of our the height of a prism was 16.0 centimeters. We'll make that the longest dimension. Now our top is going to be 4.6 times 5.4. Which means we are limited to a cylinder of radius 2.3 centimeters. That's the biggest radius we can have. It's half of this side. We can't have a 2.7 centimeter because then that's 5.4 across. It doesn't fit this way. So we're looking at a cylinder. Volume is pi r squared h. Pi 2.3 centimeters squared times a 16.0 centimeter. So pi times 2.3 squared times 16 is pi times 2.3 squared and our 16.0. 265.9 is the volume to the nearest square. Is 266 centimeters squared. Of course, for full credit, you need all the steps, not just the number. If the cylinder is placed in the prism and the remaining volume is filled with water, how much water is necessary? Well, that's the volume of our prism minus the volume of our cylinder. Volume of our prism is 16 by 4.6 by 5.4. And from that, we subtract the volume of the cylinder that we just got. 131.53559. So 13, and it was 1 point, but we're asked to the nearest centimeter. So that's going to come out to 132. So we have an orange radius of 3.5 centimeters. It's divided into 16 equal segments by cutting it in halves. What is the combined surface area of all the segments? Okay. So let's do a top view of our orange. We can assume a perfectly spherical orange. It's been cut in 2, 4, 8, and now 16. So when we cut our orange into segments, the surface area where the peel shows is just the surface area of our orange. So the part with the peel is just 4 pi r squared. Now each segment, right, if we sketch our segments here, really tough to sketch. We're going to have the peel part, and we're going to have 2 hemispheres. So the area of a circle is pi r squared. We have half of that on the front, half of that on the back. So that pi r squared is the area of an entire circle. N is the number of segments. Pi r squared, oh, but we're not dividing by n because that's how many we have, times n. So this works out to 4 pi r squared plus n pi r squared, or if we want to factor, 4 plus n pi r squared. Now here, our radius is 3.5 and our n is 16. So 4 plus 16 times pi. Our radius is 3.5 centimeters. 3.5 squared. So that's about 770 when we're asked the nearest square centimeter. Again, if you are not sure about your rounding, instead of having the decimal float forever it wants, you can even say 0 decimal places. And that gives it to us, to the nearest whole. So here we have 770. That wraps up measurement 3 on surface area and volume. Here we go. Last outcome on the assessment, measurement 4, trigonometry. So this time we are given side B, that's the bottom, and angle A. So we're given an adjacent angle. We need to completely solve the triangle. So we're asked first for the hypotenuse. Given adjacent and the angle, right, we can use our cosine. So ka toa. So the cosine of angle A is B over C. So that tells us the hypotenuse is B over the cosine of A. Now here our angle is 31.1 and B is 34.1. Now notice our angle mode. It's in radians. I said notice because it's written right at the top on these calculators. It says degree. If yours doesn't have that display, if you're not sure, take the inverse tan of 1. If you don't get 45, you're in the wrong mode. Anyway, B over the cosine of the angle is 34.1 divided by the cosine of 30. Oh, the angle was 31.1. Oh, yeah. Almost did that backwards. There we go. So our hypotenuse is 39.8. Again, if you're not sure about your rounding, this entire set is to the nearest tenth. So you can make it 1 decimal place. There we go, 39.8. We need angle A. That's going to be using opposite and adjacent. So here, tan A, we're given the adjacent side. So the opposite is lowercase a, we're given lowercase b. So that means our opposite side is B times the tan of angle A. Going back to our calculator, 34.1 times the 10 of 31.1. Forcing it to one decimal place, that gives us 20.6. In reality, that's an irrational number. I have a whole lot more. And finally, our angle B. The three angles in a triangle add up to 90. One is already a right angle. So we just take 90 minus 31.1. And that gives us 58.9. We're going to see a lot of irrational numbers as we are doing these in our trigonometric outcomes. So we might as well leave our calculator here until we know what decimal place we need. So the top of the tower is 200 meters high. Angle of depression to a conservation officer on the ground is 8 degrees. Want to draw the fire tower, the officer, and a triangle you can use. So here's our tower. Boop-a-doop. Rectangular tower. Now the officer is the tower is 200 meters high, and the angle of depression. So the angle of depression is looking down. Not in the sense that we feel superior. It's just the way it's defined. So we're looking down 8.0 degrees. The height of our tower is 200 meters. This angle would also be 8.0 degrees. That's a right angle. We know our height is 200 meters. And this is our unknown. So really, this is a tan problem. This is all we need for the diagram. So our diagram is done. So that's on the whiteboard. Now notice the top of the tower is given to us in meters. We're asked for the distance in kilometers. This is probably going to be easier if we change our units here first. So divided by 1,000, this is 0.200 kilometers high. Now we are given the opposite. We're asked for adjacent. So tan theta is the opposite over adjacent, which means the adjacent side is going to be the opposite over the tan of theta. Now we are asked the nearest hundredth. Nearest hundredth is 2 decimal places. Okay, our distance is 0.2. Our angle is 8. So we're taking 0.2 kilometers divided by the tan of 8 degrees. You put in the 0.0 if you want. It comes out to 1.42 kilometers. So, if everything goes as planned, this should conclude our assessment. Unpausing for a moment, I said if all goes as well, it'll be here. Doing the calculation on this, I slipped a sign. So that actually should have simplified to 7. All right, so with that one correction, then we do find we end up with that perfect score we are looking for.